Right, so we are going to go ahead and get into section 7.3, which is multiplying special cases. And this section is much shorter than the previous section, so it'll give you guys a little bit of a break. So when we are multiplying binomials, there are a couple of special cases. So for instance, the first one is squaring a binomial. So if I am taking this binomial a plus b and I am squaring it, it always ends up being a squared plus 2 times ab plus b squared, and I'm going to show you why this works. So remember, when we square something, it's telling you that you are multiplying that thing by itself. Okay, so if I were to use my FOIL method, I have a times a gives me a squared plus my outer a times b plus right here b times a, which is the same as a times b, and then our last, which is plus b squared. So if I combine like terms, I get a squared plus 2ab plus b squared. Okay, so this happens every single time that we are squaring a binomial. So let's practice with this a little bit. So 5x is going to be my a, and then negative 3 will be my b value. So first, I have a squared. Okay, so remember, when I'm squaring this, it is the whole thing squared. Okay, plus 2 of my a value times my b value, and then plus this b value squared. So if I look, 5x squared, 5 squared is 25, and then x squared plus 5x times negative 3 is negative 15x, and I'm going to double that. So I actually don't want a plus sign there. I want a minus 30x, and then plus negative 3 squared is going to be a positive 9. It's always a plus sign here because anything squared is always positive. Okay, so again, we had our a value, which was 5x. We squared it to get the first term. We took our a and b value and multiplied them together. So 5x times negative 3 gave us a negative 15x, and then we just doubled it to get a negative 30x. And then we took our b value of negative 3 and squared it to get that positive 9. Alright, so we're going to do the same thing over here, except I'm going to skip the second step right here, and I'm going to go straight into writing it exactly how we would see it. So 3x is my a value, and negative 4 is my b value. So first, I'm going to square my a value, so 3x squared. So 3 squared is 9, and then my x squared. And then I'm going to multiply a and b together. So 3x times a negative 4 would be negative 12x. But remember, we need 2 of them. So I'm going to double that to give me a negative 24x. And then plus my b value of negative 4 squared, which is 16. Okay, so I didn't have to go through and do the foiling method. I didn't need to write everything out. I could just follow this simple formula here to help me kind of speed up the process a little bit. This also works with numbers. Okay, so if I think about the number 29 squared, okay, 29 is the same as saying 30 minus 1 squared. Okay, so 30 squared is going to be 900. 30 times a negative 1 is negative 30, but we're going to double that to make it negative 60. And then plus negative 1 squared, which is 1. So 900 minus 60 gives us 840, plus 1 gives us 841. Okay, so if you were to check that on your calculator, if you did 29 times 29 or 29 squared, you would see that you do in fact get 841. Our second example, 71, is the same as saying 70 plus 1 squared. So 70 squared, if I think of 7 squared, I know that that's 49, and then I would have 2 more zeros because it's 70 times 70. All right, and then we have our 2ab, so a times b, 70 times 1 is just going to be 70, but we double that, so we would get 140. And then plus our b value squared, which is 1. So if I take 4,900 and add 140 and add 1, I should get, let's see, 4,900 plus 140, that would be 5,040, so 5,041. So if you, on your calculator, do 71 times 71, or 71 squared, you do in fact get 5,041. Okay, so you can break apart numbers, and for 71 squared, off the top of my head, I couldn't tell you what 71 squared is, but by breaking it up into 70 plus 1 and squaring that, and then following our squaring a binomial rule up here, I was able to do it without a calculator and find that it was 5,041. So it's actually kind of cool. All right, the next thing that we are going to look at is the product of the sum and difference. Okay, again, we've got binomials. So we have a plus b times a minus b. Okay, that means that our terms are going to be the same. The only difference is one has a plus in between, one has a minus. And every time this becomes a squared minus b squared. Okay, so let's look and see why this happens. Okay, so let's FOIL it out. We get a squared minus a times b plus a times b, and then minus b squared. And if we look, these two terms in the middle are going to cancel out. So we do end up with that a squared minus b squared. Okay, so this one is actually going to be pretty simple. If I look, here's my a term. They're both 5x. And my b term is going to be 7. So I'm going to take my a term and square it and subtract my b term squared. So 5x, the whole quantity squared, is going to be 25x squared minus 7 squared, which is 49. And that's it. It's done. In our second example, note that both of our binomials have an a term of 2x, and both binomials have a b term of 4. So since a and b are the same, and we have a minus and a plus sign, that means that we can follow this rule. So 2x, take it and square it, we get 4x squared, minus our b value of 4, you square it, and you get 16. And that problem is done. So we can actually use this again to find products of numbers. So if we look at 43 and 37, so 43, we can break this into 40 plus 3. And then 37, we can actually turn into 40 minus 3. Notice how our a terms are the same, our b terms are the same, and then we have one's a plus and one is a minus. All right, so if I did my a term squared, so 40 squared, so 4 squared is 16, and then we add our 2 zeros, minus our b term squared, so 3 squared, which is 9, we get 1,591. Okay, so if you were to pull up your calculator and do 43 times 37, you do in fact get 1,591. So that's pretty cool. All right, so our second example, we can look at 56 as 50 plus 6. And if we look at 44, that is 50 minus 6. So again, we've got our A terms and our B terms. Okay, so 50 squared. So 5 times 5 is 25. And then, of course, we bring our two zeros minus our 6 squared, which is 36. All right, so if we do 2,500 minus 36, we get 2,464. And again, if you were to type into your calculator 56 times 44, you would get 2,464. So I thought that was kind of cool. I had seen these special products before, but I had never actually seen them used with these types of examples down here with the numbers. So that is actually pretty cool to me. I find that really interesting, so I kind of learned that part with you guys. So you do have a Pearson assignment to do with this, of course. It is uploaded on Pearson. If you have any questions, email me or message me through Remind and just let me know. Good luck.